when an Indian farmer picked up the remains of a missile inscribed with PL-15E, a question that shook South Asia instantly exploded in the Global Military Observatory. Could this piece of metal, with the smell of smoke, really give Indian military engineers a glimpse into the core secrets of China's top air-to-air missiles? This piece of trophy from the sky, from the Pakistani Air Force in the border conflict, launched PL-15E missiles. It is 135 kilometers of ultra-long-range precision hunting Indian Air Force worth $240 million of Rafale fighter aircraft. Creating a modern air warfare, it has created a legend in the history of modern air combat. While Western think tanks eagerly discussed the possibility of reverse engineering, and New Delhi laboratories worked overnight to formulate analysis plans, Chinese Defense Ministry spokesman Zhang Xiaogang's response was surprisingly calm. The PL-15E is an exportable piece of equipment and has long been unveiled many times at domestic and international defense exhibitions. Behind this glib statement is China's military-industrial system on the technology generation gap of absolute confidence. Want to not have to steal to pick up shelf products at your disposal? Carefully scrutinize the wreckage obtained by India. The cruel technical reality immediately surfaced. This piece of metal, rendered as treasure by the media, but is only half of the shell of the missile propulsion section. The real core technology components, equivalent to the missile's brain, of gallium nitride active phased array radar guide head, as well as act as the teeth of destruction of the high explosive combat section. As early as hitting the target, the moment of hitting the target has completed the self-destruct program. Even if the shell is relatively intact, its internal double-pulse engine structure is tightly wrapped in multiple layers of composite armor. Any forced disassembly will trigger the embedded self-destruction device, ultimately leaving a pile of twisted alloy debris. What is more ironic is that the wreckage label is clearly marked with the words "Factory in 2015", which means that India regarded as a treasure, but as a medium-tech product that China disclosed to the public a decade ago. For the lack of a complete military-industrial system of India, this is the same as picking up a screen-broken smartphone, can recognize the brand model, but cannot repair the function, more likely to copy the underlying chip architecture. India's military-industrial sector is facing a dilemma far beyond the wreckage of the wreckage. The triple technological rift valley is almost insurmountable, even if the whole country is mobilized to attack it. First in front of the double-pulse engine is the rhythm of the mystery. PL-15E can be unique in the global air-to-air missile. The core lies in its double-pulse solid rocket engine engineering applications. This technology is currently only achieved in China. This technology has only been realized by China. Its subtlety lies in the two intelligent ignition, the first section of the missile to promote high speed to meet the enemy when the target aircraft emergency maneuver to avoid, the second section of the end of a sudden second ignition to achieve fatal acceleration. This breathing thrust distribution involves combustion chamber hydrodynamic design, propellant nanoscale ratio, millisecond ignition timing control, and other composite technologies. India has spent 3 decades of research and development. Kavli aero engine still ended in failure, and the United States Raytheon and the AIM-120D missile on the double pulse attempts also due to fuel management algorithms bottlenecks declared shelved. For even the basic turbine blade casting process has not been fully mastered by the Indian military industry, even if the complete design drawings, but also unable to break through the high-temperature materials and precision control of the engineering barriers. The second fatal barrier from the missiles, intelligent eye. PL-15E, equipped with gallium nitride active phased array radar guide head, known as the pinnacle of micro-radar technology. Within the space of the warhead, which is only 20 centimeters in diameter, Chinese engineers have integrated thousands of tier components made of gallium nitride. This third-generation semiconductor material is 5 times more resistant to high voltages than traditional gallium arsenide, and 3 times more efficient at dissipating heat, increasing detection range by 30%. However, manufacturing such components requires vapor deposition growth of ultra-high purity gallium nitride crystals, micron-level soldering precision, and quantum-level electromagnetic compatibility design. India has so far failed to establish a complete military semiconductor industry chain. Its domestic, Astra, missiles are still using mechanical, scanning radar, anti-electronic interference capability lags behind a whole generation. The most desperate India may be the system integration of the ecological predicament. Modern air war has long exceeded the performance of a single weapon. The key to victory lies in the deep integration of combat systems. PL-15E through two-way data chain, and ZDK-03 early warning aircraft, J-10CE fighter aircraft active phased array radar real-time network, forming a detection, decision-making, strike, covering hundreds of kilometers of the kill chain. On the contrary, the Indian Air Force, Rafale, fighter using the French blockade of the source code, Su-30MKI rely on the Russian data chain, domestic LCA, Glory. Fighter avionics system compatibility is insufficient. This universal brand equipment system has led to each platform becoming an information island. Even if the miraculous imitation of the PL-15E, but also can not access the existing combat network, as to the old-fashioned radio with a 5G chip, the hardware can be forced to put together the system ecology but completely cut off. India's military industries predicament is rooted in the structural lack of independent innovation capability. Although the Modi government high-profile promotion of Make in India strategy, but the bureaucratic problems of the Defense Research and Development Organization is difficult to return. With 41 laboratories and more than 20,000 researchers, the organization has been criticized for its chaotic management of projects, and a 2024 committee of defense experts recommended splitting it into 10 national laboratories, but the reforms were aborted due to resistance from vested interests. Private sector participation is even more limited. The DRDO maintains a monopoly by opening up only marginal technology transfers to the private sector. The military R&D sector requires huge investment, and in the absence of a clear commitment to procurement, India's private sector would rather invest in consumer electronics than in the military. More fatal is the serious shortage of R&D investment. India's defense R&D funding only accounted for 5%-6% of military spending, far lower than the United States, France and other countries 10% of the level. The national scientific research investment in the proportion of GDP for a long time, hovering at 0.7%, less than Brazil, South Africa, and other emerging countries. This mismatch of resources has led to India's military industry into the pulling the seedling to grow circle. In order to demonstrate the status of a great power, the limited resources to hypersonic missiles and other face-saving projects, but even the basic missiles have not eaten through. Astra, missile research and development for 27 years at a cost of tens of billions of rupees. The range is still less than 100 kilometers. Su-30MKI platform test fire 7 times failed 4 times. The lessons of history are clear. When Israel provided Derby missile technology, India's imitation due to insufficient materials and technology, the weight increased by 30% and the range of the waist cut. China's Ministry of Defense direct purchase of the COM statement, in fact, is the systematic externalization of technological confidence. This self-confidence comes first from the strict management of technology classification. Self-use PL-15 ramjet engine, range exceeds 200 kilometers, can be built into the J-20 NHL, foreign trade version of the PL-15E through the restriction of fuel loading, simplified guidance algorithms, not only in line with the missile technology control regime, but also to maintain the structure of the advanced. Deeper is the business model change. China's military industry is from the single weapon sales to combat system output. Military sales to Pakistan not only contains the missile body, more supporting ZDK-03 early warning aircraft, high-speed data chain system, and even localized production line. In Islamabad to build a complete air warfare ecosystem. This systematic ability is precisely the wreckage reverse engineering. Can never be copied core competitiveness. The legal net of protection is equally tight. According to the regulations on export control of missiles and related items and technologies, China implements a hierarchy of licensing for the export of missile technology, and any unauthorized transfer of technology triggers criminal prosecution. Even if India were to try to acquire key technologies through third countries, the complex international compliance scrutiny would make it difficult. The brutal laws of modern warfare have long since declared the wreckage imitation theory completely bankrupt. China's military industry's deep-rooted backbone comes from continuous innovation. PL-17 with a range of 400 kilometers and speed of Mach 6 has already been deployed in combat, and its double-cone warhead design can break through any existing air defense system. While Indian engineers are still analyzing the remnants of a decade-old engine under a microscope, the tail flames of the next-generation Thunderbolt missiles are already lighting up the night sky at the Chengdu Aircraft Design Institute's test range.